Hello! In this tutorial, we're going to be talking about Grasshopper data types. We're going to start by picking some parameter objects from the component palettes. So under params, primitive, I'm going to pick a Boolean container. I'm also going to grab a panel. And then under params input, I'm also gonna take Boolean toggle so that we can generate Boolean value and see the output. In this case, these two values are true or false. So let's perform the first conversion that is possible in Grasshopper. Let's go under params, primitive, pick integer container, and let's input Boolean value into the integer container. Just transfer through the integer container, and we see that Grasshopper was able to automatically convert false value into an integer value of 0. And if I double click on Boolean toggle and turn it to true, then the integer value becomes 1. So false is 0 and true is 1. If we go under params, primitive, and grab a floating number parameter, connect the Boolean value and the panel to the output, you can see that in this case it performs the same way as integer, but of course floating number could be any other number as well. So just a note. Let's grab another one, text. This one also performs a straightforward conversion. So we can just read the Boolean value, but it's a text. Okay, so far so good. Let's go under primitive and choose color container. So this is something that Grasshopper would not be able to convert automatically. And we see the red balloon, and if you hover over it, you can see that it says data conversion failed from Boolean to color. So there is no defined way for Grasshopper to know what color would be the false value or true value. Let's go under params, geometry, and try surface parameter, and we have the same problem. I'm gonna select all of these objects on canvas and make a copy and move one of the copies to the right. Then go under params, utilities, choose the rely object, and using Control-Shift keys, I'm gonna reconnect all the wires from the Boolean toggle to the rely object. Now let's go under params, input, and grab a number slider. And this number slider is going to replace the previous Boolean toggle. Okay, so let's have a look how Grasshopper managed to automatically convert this floating number into other types of data. So with the Boolean one, if the number slider is 0, then the Boolean outputs false, and if something above 0, then it becomes true. The integer does a sort of rounding. So as soon as I hit 0.5, so half with my number slider, then the integer outputs 1. So again, the rounding. A number parameter just transfers the data as is, similar with the text. And we also have the same issue as we did with the Boolean input, that Grasshopper couldn't convert floating number parameter to color or surface. So in these two examples, we have some useful conversions. And in fact, Boolean, number, and text conversions are some of the most widely used data conversions in Grasshopper. Let's explore more. Let's go under curve, primitive, and choose to create a circle. So we can now already see a small circle in Rhino, And the circle component requires a plane as an input, a base plane, and its default plane is world x, y. And it also requires a radius to define the size of the circle. So let's go under params, input, and choose number slider. Or we could also double click on canvas, and we can type in the minimum and maximum values for our number slider. So let's say from 1.0 to 10, and click enter. Connect to the radius input. I'm also gonna grab a panel so that I'm able to see the output. And now let's see what sort of data conversions we can do with the circle in Grasshopper. I'm gonna begin with Boolean. Under params primitive, connect the output of the circle, and you see that the Boolean value is true. And this is because my circle radius is always above 0. If we double click on the number slider and set the minimum value to be 0, click OK. Then as soon as I create this non-existing circle, because the radius is 0, then the Boolean value becomes false. So if I have a circle, then it's true, and if there's no circle, then it's false. Let's continue. Let's grab a surface parameter, connect to the circle output, and as you can see, it worked. The conversion worked, and this is a very useful data conversion within Grasshopper. So any closed planar, curve, or polyline in Grasshopper can be automatically converted into a trimmed surface. I'm gonna go grab a point param object now, connect the output of the circle, copy the panel, and in the panel you can see that we have the coordinates of this point, which is 0, 0, 0. So this point is the center point of the circle. So if I grab another point parameter, right click on it and set different kind of coordinate, different point, input instead of the default point position, you can see now that the center point of this circle is changing, and also the coordinates in the output panel, you can see that it's changing as well. I'm gonna delete this input point for now. So let's go back to the component palettes under params geometry. Let's grab mesh container and connect the output of the circle component to the mesh container. I'm going to turn off the surface preview here, and you see that we have the mesh created here. So this conversion was successful, and the topology of the mesh, or the meshing here, is done using default Grasshopper settings for meshing. Let's keep exploring. Let's go under params geometry and try to find something new. Box. Let's connect the circle output to the box container, and you can see that the conversion was successful. I'm going to grab a panel so we can read the output as well. So it says a flat box, and this box is a sort of bounding box created around this circle, or to contain the circle, based on a current default world XY coordinate system. Under params primitive, let's pick text and connect circle output to text container. This conversion is also successful. I see no errors, and in the panel you can see that it says circle. So as you can see, with this circle, or this closed curve, there are a lot of conversions possible within Grasshopper. And let's try something that caused us problems in previous examples. Under primitive, let's pick color container, and let's connect the circle. Okay, so surprisingly, even this conversion is successful in Grasshopper. But if we grab a panel and read what is inside here, so I predict this an RGB code for color. I'm just going to move the script a bit. But it's difficult to say why this exact color is assigned to the circle conversion. So for if I move, let's say, the radius of the circle, this value doesn't change, so it's not based on the size of the circle. We can also maybe try to change the position of the circle, but the value still is not changing. So it's sometimes, even though the conversion is possible, it could be difficult for regular users for us to actually understand the use of such conversion. So sometimes it's possible but not necessarily meaningful. The last topic in this tutorial is going to be point to vector conversion. So it's also one of the most popular conversions in Grasshopper. Let's go under params, geometry, pick a point container. It's empty. Let's right click on it and choose set one point and pick a point in Rhino window. And under display, you can choose to turn on gumball option in Grasshopper, so we can move this point around. Okay, now let's go back to params, geometry, and choose vector container. And let's connect point to vector, and also let's grab a panel. And in the panel you can see that both the point and the vector is considered as a set of coordinates. I'm gonna return my coordinates, my point into 0, 0, 0. And by default, vector is not visible in Grasshopper. We have to go to the component palettes under display, vector, and choose vector display component. So the vector display component requires an anchor point and a vector. So I'm going to choose the vector that I have just converted to input here. And for the anchor point, I'm going to double click on canvas and type in one-sided quotes and 0, 0, 0. And connect this panel to the input of an anchor point for the display vector component. So now as I select the point, the initial point, and move it using a gumball, you can see the vector that's being created in Rhino window. So let's discuss this conversion. Grasshopper takes the initial input point as a target point or point B in a vector, and the origin point or the start point is always the 0, 0, 0 of the default coordinate system. So if I create a let's copy this vector display component and let's change the origin of the second vector display. So now the origin of the second vector is the point B, or the target point of the first vector, but it's the copy of the same vector just moved to a different origin. So if I change the initial point, you can see that both of these vectors have the same length or magnitude and direction. So this is a very important concept to grasp, that in programming, a point can be considered both as a coordinate and as a vector. Okay, so I think we have covered all that I wanted to cover in this tutorial. In the next one, we're going to talk about concepts of constructing and deconstructing data. So I'll see you then.